last time we had looked at multiplying radicals, multiplying binomials with radicals. Now we're going to look at some division. Supposing we want to divide two radicals. So for example, the square root of 14 divided by the square root of 7. We can combine those underneath the root. So we have the square root of 14 over 7. We could do the division now. 14 divided by 7 is 2. So we have the square root of 2. So that would be the simplification of that division. What about if we have variables? Here we have the square root of 12x cubed over the square root of 3x. So we can combine them underneath one root. So the square root of 12x cubed divided by 3x. And we see that 12 divided by 3 can be simplified to 4. And x cubed divided by x is x squared. And so now we can simplify this one more step, hopefully. We can say, well, the square root of 4 is 2. And the square root of x squared is just x. So we end up with 2x as our final simplified version. Now dividing radicals is a very important tool to know when you're doing algebra. And one special division tool we're going to learn is called rationalizing the denominator. Let's take a look at that. Alright, in this problem we're asked to rationalize the denominator of this fraction, the square root of 5 over the square root of 12. And the idea is this root down here is irrational. A square root is irrational unless you have a perfect square underneath, and we don't here. So square root of 12 is irrational, and we want to rationalize it and replace it with a rational number. So how do we do this? The first thing you must do when you have a problem is try and simplify if you can. You may notice that the square root of 12 can be written as the square root of 4 times 3. And so we can square root the 4 to get 2 on the outside. And so we have square root of 5 divided by 2 root 3. So this is the same problem, but the denominator is now a little bit simplified. So let's put this down on the next row. So how do you rationalize the square root of 5 divided by 2 root 3? We still have a square root here. What we do is we multiply top and bottom by the square root of 3. By that denominator we want to rationalize. So if we take the bottom times root 3 and the top times root 3, and then we do a multiplication spread across just like fractions. Root 5 times root 3 and 2 root 3 times root 3. So root 5 times root 3 becomes the square root of 15. And 2 root 3 times root 3, well, root 3 times root 3 gives me 3. So we'll have 2 times 3. And then that simplifies further to the square root of 15 over 2 times 3 is 6. And so there's our final answer, and the denominator is now a rational number, 6. Let's take some more complicated examples with rationalizing the denominator.
Rationalizing 1 over the square root of 2. To do so, we will multiply 1 over the square root of 2 times root 2 over root 2, since root 2 is the irrational number. Notice we are multiplying by 1. Doing the multiplication, on the top we will get 1 times the square root of 2, which will equal the square root of 2, and on the bottom we will get root 2 times root 2, which will equal 2, since the square root times the square root undoes itself. Rationalize the denominator of 1 over the square root of x plus 2. To do so, we need to multiply both top and bottom by the conjugate of the square root of x plus 2. The conjugate of the square root of x plus 2 is the square root of x minus 2. Notice we are multiplying the fraction by nothing more than 1. Doing our multiplication, on the top, 1 times the square root of x minus 2 will just leave us with the square root of x minus 2. On the bottom, we have to FOIL. Square root of x times the square root of x is x, minus 2 times the square root of x, plus 2 times the square root of x, which gives us 0, plus 2 times minus 2 gives you minus 4. So our final simplified fraction is the square root of x minus 2 divided by x minus 4.
Rationalize the denominator of 2 divided by root 5 minus root 3. We see in the denominator these are irrational numbers, these square roots, and so we want to rationalize that. In order to do this problem, we have to multiply both the top and bottom by what's called the conjugate of the denominator. The conjugate of this denominator, root 5 minus root 3, is root 5 plus root 3. The only difference is the plus and the negative here. We do that to both the bottom and the top. Once we take the product of these, the top becomes 2 times root 5 plus root 3, and the bottom, since we're multiplying what's a difference and a sum, the middle term will drop out, and we're left with root 5 times root 5 is 5, and root 3, negative root 3 times plus root 3 is negative 3, because when we FOIL it, the middle term drops out. We see that 5 minus 3 is 2 on the bottom, and these 2's cancel to leave us with root 5 plus root 3.